Bismillahirrahmanirrahim. Assalamu alaikum everyone. In this video tutorial, we are going to talk about binary number system, and it is the second video of this series, which is number system. So in last tutorial, we talked about decimal number system. In this video tutorial, we are going to discuss another number system, that is binary. The word binary itself means two, right? And why does it hold to? As we discussed in the last tutorial, that decimal number system holds how many number of symbols or numbers? 10. So binary number system holds two or only binary numbers. That means it have only two possible symbols. And since we talk about two, so we know that count starts from zero. So very first number that is going to be used in this video or in this binary number system is what? 0. And the next number is what? 1. So we have only these two possible options available in binary number system. So if we talk about how binary number system can be grown or it can be extended to large number of iterations, so very first possible number would be what? Simply 0. The next number would be what? 1. And now we have to produce the same logic, or we have to use the same logic to grow the binary number system. The second or the third option would be what? 1, and 0 will be used as a non-significant member. So the third member is what? 1 0. So what would be the next iteration? That would be what? 1 1. Now we don't have any other numbers, so that means we have all possible two combinations have been done in 2 digits, so we have to go to 3 digit format. Now it will be what? 1 0 0, and then we have to increase in this way 1 0 1. So this is how this sequence goes on, and you will eventually find out you will stuck on 1 1 1. Or if you continue this series on eighth combination, you will receive 1 1 1, right? Similarly, on fourth combination, at the end you will have 1 1, 4 times 1. So this is how this number system will be grown, right? Or this is a, and you can see that there are only two possible options for symbols to be used. Either it will be 0 or it will be 1. So this is the one aspect of this video tutorial. And the next thing, we know that number in binary system is given, and we need to know what is its equivalent decimal. So how you can calculate that equivalent decimal, or how you can convert a binary number into a decimal number. For that purpose, we need to calculate the weight of every position. For example, we have already discussed the weight concept in the last tutorial, but I'm going to explain it again from the perspective of binary numbers. So let's say we have 4-bit binary number, and that is 1 0 1 1. So you know that its base is what? 2. We have already discussed the number of symbols is known as base or radix. So its base is 2. So that means we will be using power of 2 or exponent of 2 to calculate the weight of every position. So this is the zeroth position, so that would be what? 2 power 0, right? That is basically first position, so 2 power 1. That is what? Second position, so that would be what? 2 power 2. And it is what? Fourth or third position, so that would be what? 2 power 3. So this is how you will grow the weight. If you have 5-bit number, so it will go up to 2 power 4. If you have 3-bit number, it will go up to 2 power 2. So that's how you will eventually calculate the weight of every position in binary number system. But one thing more, the most commonly binary numbers are found either in 4-bit format, right? Like this is an example of 4-bit format, or it could be found in 8-bit format, or 7-bit format. 7-bit format is basically used for ASCII, which is very well known number system again. And the other format is 8-bit. 8-bit is very well known because it is found in normal keyboard. Extended ASCII is related to 8-bit decimal. So we need to know the 8-bit or 4-bit on tips fingers, though, so that you can actually calculate directly. For example, you know that 2 power 0 means what? 1. 2 power 1 means 2. Then 2 power 2 means 4. 8. So what would be next 4? It would be simply double of previous one, that would be 16, then 32, right? Then 64. And what will be the eighth digit or seventh position? That would be what? 128. So this is the number format if you will be following in case of if we are talking about 8-bit binary number system. And if we talk about only 4, then we will be using uh, only this one. These. So this is what, this is the area of what, 4-bit, and this is the area of 16-bit. So let's talk about the number system conversion, and I'm going to explain it with certain examples. So let's take some examples. Okay, for the purpose of easiness, I've just written these corresponding weightage in case of 8. So let's say we have a number given and it is just 3-bit, that is 101. So how to calculate? You know that 1 will be associated with this 1, 2 will be associated with 0, and 4. So 0 you will not count because 0 will multiply it with these weightage. So that is basically what 1, and that is basically what 4. So 1 plus 4, that means 101 is equal to 5 in decimal. So that is means 101 in binary, right? You can simply say the base is binary, is equal to 5 in base 10 or 5 in decimal, right? Similarly, you can use another example. Let's say I'm gonna use this example. This is very uh, interesting example because we will be using in hexadecimal format as well. 110, right? So this is 4-bit example. So this is one's position, this is 2, and this is what, 4, and this is 8. So you know that these two numbers will be gone because they will be multiplied with 0, but 4 will multiply it with 1 and 8 will multiply it with 1. So that means 8 plus 4, that means it is equal to 12. So that means 1100 in binary, it is equivalent to what? 12 in decimal, or 12 in base 10 system. I hope you have understand this binary to decimal conversion. Still, if you have any confusion regarding binary to decimal conversion, you can post your queries in comment section. Thank you so much for listening.